Trigonometry, Chapter 7, Applications of Trigonometry, Vectors, Section 2, The Law of Cosines, Video 2, The Law of Cosines, Example 1. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. The previous video, we learned about the law of cosines. Specifically, in triangle ABC, a squared equals b squared plus c squared minus 2bc cosine A, or b squared equals a squared plus c squared minus 2ac cosine B, or c squared equals a squared plus b squared minus 2ab cosine C. All of the variables represent sides except the arguments of the trig functions, the argument of the cosine. But in general, for any triangle where you focus on a particular angle, the square of the opposite side is equal to the sum of the squares of the adjacent sides minus 2 times the product of the adjacent sides times the cosine of that angle. In this video, we look at a problem that uses the law of cosines. This is actually a surveying problem. For example, a surveyor wishes to find the distance between two inaccessible points A and B on opposite sides of a lake. We'll label that distance C. While standing at point C, he measures side A equal to 423 meters and side B equal to 259 meters. And the measure of angle ACB is 132 degrees 40 minutes. Find the distance C across the lake. This image courtesy of Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. Now, it's worth mentioning that in a surveying problem or a real world situation like this, a lot of times the letters are not labeled, but for communication purposes, it's ideal to do that so you can make it impossible to miscommunicate. So we're choosing to call the point where the surveyor is standing C, while A and B are the points on the lake, forcing the opposite sides to be called A, B, and C. Now, when analyzing a triangle problem, recall that in order to use the law of sines, we must have a complete angle side pair. So since we only know side A, side B, and angle C, we cannot use the law of sines. Thus, the law of cosines will be used. The other thing that says the law of cosines is good is that we have an angle and the value of the two included sides. Using c squared equals a squared plus b squared minus 2ab cosine C, or the generic version in terms of opposite and adjacent, we have c squared equals 423 squared plus 259 squared minus 2 times 423 times 259 times cosine of 132 degrees 40 minutes. Now, so at this point, a lot of people want to start using their calculator, and honestly, that's okay. But if you write down a rounded value and then use it subsequently, your answer is going to be more off than you would want it to be sometimes. So when it's a choice between approximating or solving for a variable, I will always solve first because that choice does not bring error into the value. So in other words, I'm going to go ahead and square root both sides to meet the objective of getting C by itself, and then use a calculator at the end. So drop a big square root over both sides. That would cancel the square on the C on the left. And on the right, we have the square root of 423 squared plus 259 squared minus 2 times 423 times 259 times cosine of 132 degrees 40 minutes. And using your impeccable calculator skills, you could use a calculator and get that this is approximately 628 meters. I think the hardest part about this is actually using the calculator. Now you try. Pause the video and try the following. The Vietnam Veterans Memorial in Washington, D.C. is V-shaped with equal sides of length 246.75 feet. The angle between the sides is 125 degrees 12 minutes. Find the distance between the ends of the memorial. Pause the video and give it a try. All right, here's your fair warning if you haven't paused the video and tried the problem. Solution in 3, 2, and 1. Now, I did opt in the solution to write the missing sides length as C. In retrospect, I wish I had actually used opposite since there's no letters and variables in this. But regardless, using the law of cosines, we get C squared equals the sum of the squares of the adjacent sides to the angle minus 2 times the product of the adjacent sides times the cosine of the angle in between. Take the square root of both sides and then use a calculator, and you get the distance between the ends of the memorial is approximately 438.14 feet.